Good evening, everyone. Today's session is on applications of NLP. So, NLP is one of the domain of artificial intelligence, right? And what we have in NLP is it's a language processing. We have language processing algorithms. So, NLP stands for Natural Language Processing. The library for natural language processing is NLTK, Natural Language Toolkit. So through this application, like whatever the applications we have in NLP, there are a number of applications and we all are using those applications. Right? They may be rule based applications, they may be AI enabled applications. Like suppose I'm talking about your if I'm moving to a website and there comes a chatbot, right? I can chat with that chatbot. It is going to provide me the answers of that particular application only. Like suppose taking an example of HDFC. I'm just typing on Google HDFC and going into that website, and then there comes a HDFC EVA, a chatbot, which is going to provide the applications, which are going to provide the answers basically that are related to HDFC Bank. So some rules are fed into that chatbot that is going to answer according to that. If I'm going to ask any other question from that HDFC EVA, it won't be able to give me the answer. Why? Because the rules that are fed into that machine is only up to that particular specific application. Right. Whereas when we have our Google Assistant, our Google Nest, Alexa, Siri, Cortana, these are the AI enabled chatbots which are going to understand our different questions related to journal domain. Like it's a journal purpose digital assistant. It is going to provide the answers not related to any specific application. They are going to provide the answers according to like whatever we are asking, right? And they are learning based systems too because they are AI enabled. So how they are implemented, how we build chatbots, there are a number of tools through which we build digital assistants or chatbots. So like you may have come across IBM Watson or Amazon or Azure. There are a number of tools, there are a number of platforms through which you can build your own digital assistant. Right. So I will be providing a session on how to build a chatbot using IBM Watson or through Amazon Web Services, that is AWS. So in coming series, we will have such kind of sessions, how to build chatbots or how these chatbots are AI enabled, how we build our rules into that chatbot, right? They all come into the domain of NLP, right? That is processing of a language, processing of a natural language. So this is called natural language processing, right? Let us start what we are going to have in our NLP. What are the applications of that? Before starting with the applications, we must know what are the uses of the computer involved language. What language use in it is involved. What are the main problems that come across when we are implementing any system or we are building any model. How success are they? Whether they are like we are building any chatbot and we can say that it is delivered in the market, it is introduced in the market, it is successful or it is not successful. So it may be like if it is providing the correct predictions, it is providing you the correct results, accurate results. So obviously that system is going to be successful. Whereas when we have some chatbot which are biased chatbots, so like after some time people are able to know like these chatbots are biased. So these systems like won't be survive much more. We need to improve those systems which are basically biased. So bias behind a system can be introduced in any form. like biased maybe in the data, the biased of the developer who was developing that chatbot, or biased in any algorithm which we are using for that particular chatbot. So when we are building any machine, the biasness come into picture. We need to check whether the system is biased or not. Why? Because it is an implication of this technology, that is artificial intelligence, right? We need to check the implications of the technology also. Like the first implication is your biasness itself. And biasness is of three types that we have just now discussed. Maybe there we have collected the data that is only containing specific data, right? Or we are not covering all the constraints, right? We are not covering all the options in that particular data set. Secondly, when we have biasness in the people means who are developing those systems. So they may be like, I'm developing a chatbot and I like blue color, so I may be feeding everything that is related to the blue color, right? Or the second example is algorithm also. So maybe some algorithm is implementing and it is going to provide you some biased results. So obviously we have to be precautious while implementing, while while building these applications, right? So let us start with today's session. What are the applications that we have in natural language processing? So the first application that is related to natural language processing is speech application. Whatever you speak is understood by the machine. Is anyone understand whether you are talking to a machine and machine is able to understand your sentence and accordingly it is going to provide you the result? How is it possible? It is possible. The reason behind that is this domain of AI, that is NLP. It is a domain which is going to have number of algorithms for processing the results. Right. So speech recognition could be speech to text. Now what is speech to text? Like I am speaking something to the system and system is going to convert it in a text. Like we have our microphones, we click on like I am maybe going into the Google Assistant, I may be using that assistant and just using microphone I am feeding some questions and that questions are to convert it into a text, and then after some time like within few seconds the assistant is going to provide me the number of results which are best suited to my question, right? So how you think is it possible? Is it any technology or is it a miracle? No, the concept behind that is natural language processing, right? So let us understand what is speech recognition, what is speech understanding. So what are the uses of this? It basically have a text dictation. We are speaking something and the system is going to convert that audio file into that text file, right? And then it searches from the data set, right? This is how we use this technology. Now what is speech understanding? Not the same. Computer must understand the intention of the user, what it is asking, right? Not the exact word. So there are some keywords which is understood by the machine, right? Like suppose I am saying I may be using the synonyms, so it may be like if it has a huge data set behind it, so it is going to identify like these are the synonyms of this word. If this word is coming, if this keyword is coming, it is going to translate this particular sentence. What are the difficulties we have while we are using the speech related application? The one of the difficulty, the one of the problem that we are facing is background noise, right? Separating speech from the background noise. Second, filtering of performance errors. So you may have some performance errors. Now how to filter that? Your keyword is filtered with that, so the sentence obviously is not understood by the machine. Recognizing individual sounds distinctions. So you may have similar phenomena. Variability in human speech, like there are different pronunciation styles used by the human. How the computer, how the system is going to understand, that would be treated as one of the difficulty, right? Ambiguity in language, you may have some homophones, like I am saying I am mailing, so it is mailing, or I'm a male. Yeah, what is, you have different homophones that are related to. Male stand for either you are sending some emails, or male stand for whether you are representing any gender. So there are number of things, like you may be like when we are building such machines, we may be come across these types of difficulties. So this is a one of the application of NLP. Now let us move to the next one. Now how we have, like in this we have speech recognition, how we have our voice recognition. Now when we have voice recognition, not really a linguistic issue, but share some of the techniques and problems. So you may have your voice and it is understood by that particular system. Now suppose this is one of the thing that is implemented through speech application. The another thing is very very important. When you type something and it should be converted to speech, so we have speech synthesis, again the same problem come across. When we have homograph, when we have naturalness, some pauses, some confusions while speaking a particular statement. So these are the difficulties which we face while building speech applications. Now let us move to some other applications that we have is word processing. Now what is word processing? What do you mean by word processing? Let us understand that. Check and correct spelling, grammar and style. You have predictive test in Google Assistant. What is predictive text? You type one word, it automatically shares a list of sentences in a drop down list. You may be typing this, you may be typing this. How it predicting? How this system, how the assistant is so intelligent that you are typing the first word and it is going to understand what will be the next word. So this is again a word is processed. It is basically the most nearest words are connected with that particular word which you are going to type, and it gives you a list of sentences through which you can select, right? So this is what word processing we have. Types of spelling errors. Nowadays when you type anything in an email or in a word file, there are number of things which going to provide the predictions, like this sentence could be this, it gives you an error. This could they gives you suggestions, this sentence, and with that particular like suggestions you may choose any of them and just click on that, it automatically completes your sentence. So what is this? This is again processing a word. Now it is very easy to identify, right? When we have spelling errors, it may when you type something and you don't easily identify some of the meanings, or maybe you are using some other word like weather. So whether the spelling, sometimes I have seen number of students have written whether instead of wh they are writing weather. So these are the typical errors which we find in every document. But with the help of such technique, we can have the suggestion like this complete sentence has the meaning and it is going to have some errors. So it basically synthesizes, it basically abstract or summarizes the particular sentence as well, the document as well. Now you have some deliberate errors in your word document, like foreign words. You may have proper names, like you have color. Nowadays color, like in our dictionary we used to train the students with COLOUR, but nowadays what we have, COLOR. So we have to understand these types of words also. They are not errors, but the system is showing the errors. Have similar meaning only. So we have such kind of system that identifies all of this thing. Now what is how to have a better word processing? Spelling checking of for homonyms, grammatical errors we can check. tune to the user. You can add your own auto corrections. So we may have auto corrections. I told you we have auto predictions also. Non-native users interference checking is can be possible. Dialytics and other special need users also can use it. Intelligent word processing, find and replace that knows about morphography, syntax, etc. So these are the examples of how, what are the advantages of word processing we have, right? Let us move to the next thing, that is text prediction. Now in text prediction, what we have is like when we are predicting, I'm typing something and the next word is predicted, right? In word processing, it is finding the spelling or the errors in grammatical mistakes, or you may be using some homonyms, right? In this also, because we are taking the language part only, we are processing the language part. What are the errors that we have in our language? So this is one of the application of natural language processing, in which we can have speed of word processing. It is a part of that only. Facilitate text dictation. You may have, like you may have microphone to use that. At lexical level, already seen in SMS, right? So you may send SMS also, and you may receive, like when you are typing on WhatsApp also, or you are using any messenger type of thing. Nowadays they are also using such kind of prediction, like your next word would be this one, your spelling is mistake, like there is some spelling error, right? So they are also using some kind of systems for have the accuracy in the prediction. More sophisticated might be based on corpus of previously seen text. So when you are learning about NLP, you may have come across number of steps while implementing any of the algorithm, right? There may be segmentation, like you may have sentence segmentation. You may have come across different like algorithm, like we have TF-IDs, or we may have tokenization before that. So there may be lemmatization, or you may be stemming for that particular word. So in later coming series, we will be learning about these particular algorithms, these particular processes, how actually we work on this. Like we have text prediction, how actually we work on this particular technique, right? Especially useful in repetitive task like translation memory or authoring memory. Suppose like you have Google Translate. It is one of the application of NLP itself. Now what does Google Translate? You give the input language, whatever you want to give as your input data, and then it is going to convert it into what, in any of the language. So Google Translate is one of the application of natural language processing itself. Next, we have dialect systems. So you have seen, you have come across number of dialect systems we have. It is very, very useful also, right? Let us understand the application of that. Computer enters a dialogue with user, usually specific cooperative task oriented dialogue. So they are specific, like if I am going to use, I have given the example of HDFC, or I may be using ICIC bank chatbot, or I am using any other chatbot. So they are specific to that particular domain only, often over the phone. Examples we have in such kind of, like suppose I am going to call somebody, and dialect system, like nowadays no one is sitting behind that, right? You maybe like I'm using big basket, right? So we have a help desk there. What we talk, what we are going to type, the dialog system is going to provide the results, right? Maybe any other site, like any of the site, like you are dealing with some healthcare sector, or in hospitals also dialect systems are used for, like in corona times, in this particular pandemic time, we have seen this, we have shortage of manpower. So these types of systems were developed, right? Usually speech driven, but text also appropriate. right? They may be like, you press 1, you press 2, you may like this, you may like that. Or for taking the feedbacks also, you may be using some dialogue systems. Model application is automatic transaction processing. So you may have, it is not only related to any kind of like you have, you are calling somewhere or you have a helpline. There are number of things behind that. If you are performing any transaction nowadays, if you put like within seconds you receive a message like your OTP is incorrect, or your someone is using your uh, this SBI card or your card. So everything is dependent on what this is. This is what we have is in dialect system. So there are number of things behind that. Domain or model will play a big part. Simplest case, choose the closest match from hidden menu to expected answers. So what it does is, it is a rule based system. Now I told you, when we are building any rule based system, we have only certain amount of keywords for which we train our machine. If we go beyond that, the machine is not able to understand, right? So according to that keyword, it is going to provide all the results. So the most closest answer that suits to this particular keyword, it gives that particular answer. So this is how we have our dialect systems implementation behind this scene, right? We used to use that, but we don't know how they actually process it, right? Now let us see some of the examples, some of the, you may say, what are the characteristics that are included in this. Topic tracking, you may search for any topic. Anaphora resolution, use of pronouns. Ellipsis, reply generation. I told you the most, you have 10 answers for this particular keyword. The most closest answer is the appropriate anaphora is used for giving the answer. Now, what are conversation machines? Basically, they are also this type of thing. Now, Turing test is what? Like if we are talking about Turing test, or we are taking any chatbot or modern versions of NLP, they are generating the language on its own. So we don't have such kind of machine right now. We have weak intelligence system, whether it is Google Assistant, whether it is Alexa, or whether it is Siri. All they are basically developed or treated as a weak AI systems. We don't have strong intelligence system because we need to implement, we need to train the machine with bundle of data set. If we don't have that bundle of data set, then we are not going to implement that particular model. Yes, IR systems are also one of the application of NLP. So in information retrieval, everyone is basically know about this, to retrieve the information from textual sources and that contain the information rather than structured databases. Now there is no need to have to read the whole database. You may use an IR system that is going to provide you the results as soon as possible, right? Processing the text to find your answers. Named entity recognition can be possible through IR systems. Name entity recognitions. Now, what is that? Typical textual sources involve names, people, places, corporations, dates, amounts, etc. Right? Named entity recognitions seeks to identify these strings and label them. Clues are often linguistic and involves recognizing synonyms and processing the anaphora. So basically anaphora is like when we have a number of pronouns, how to relate it, how to give the best possible answer to the user. The best part of automatic summarization, like I have a book of 100 pages. Now I need to read each of the page to get the summary of this page. So I may not be that much of time to read the whole book. I may be using one of the application of NLP that give me the summary of that book within a single page. So this is the advantage of automatic summarization, right? Renewed interest since mid 1990s, probably due to the growth of www. Different types of summary could be indicative with informative, abstract with extract, generic with query oriented, background with just the news, and single document with multiple documents. So the main aim behind that, to summarize that document, you need not have to read all the keywords of that particular book. You may be using this technique to get the summary of that particular book. So there are different methods. These are the different types of summary that we can have from our book as our output. Topic identification. I told you it identifies some of the keywords. It could be topic identification. It could be the some concepts like topic fusion. It may be generating the sentences also, right? Like in summary generation, we take the summary. What is the summary? It's a sentence planning to achieve the information compaction only, right? Then we have another application of NLP, that is text mining. Now text mining is what? To just extract the text from the big huge information, right? Discovery by computer of new previously unknown information by automatically extracting information from different written resources, right? Data mining, example, using consumer purchasing patterns to predict which product to place closer together on shelf. Like suppose I'm talking about, I'm purchasing some bread, right, on like Amazon, or like I'm ordering on Big Basket. How to make this cluster? Like this cluster would be having all the things which are related to vegetables, or making another cluster which is having all the things which are related to your chips or this kind of things, your snacks kind of thing, right? So this is how to get. There are number of algorithms which basically gives you the association rules. This particular item is associated with this item. Like suppose a person who is buying bread, he might be liking later on to buy a butter also. So this is how these are related to each other. Pre-processing of document collection, text categorization, text term extraction. Storage of the intermediate representations, techniques to analyze these intermediate representation through clustering. That's what I told you. Trend analysis, association rules. That's what I told you. Visualization of that particular rules, results. Story understanding. Need not to go through everything. Just use the tool of story understanding and get the results out of it. Machine translations. This is another application of NLP itself. So in machine translation, we may have some words and we need to arrange it. Like second generation took linguistic approach. We have some grammar, we have some rule system, elements of AI. Nowadays, like what we are using, use existing translate to learn translation models, either a priori statistical machine learning or machine translation. We have basically number of algorithms which are going to implement such kind of thing. How it translate it, right? Language teaching, how we call it as, like it understand our language and it basically convert it and then let us know also what is the meaning of each of the topic. Assistive computing is what? It is basically interfaces for disabled. Many devices involve language issues, that for example text simplification or summarization for users with low literacy, right? So they are very helpful for those people. Text completion, they just need to have some words, automatically it fills with the next word. Now let us conclude this session. Hope you have understood what is natural language processing, what are the different applications of natural language processing, how we have, what are the ambiguities, what are the different tools, or what are the different applications behind it, right? And before going into the detailed part of this, we should know what how to build those systems. So in coming session I will be telling you how to build a chatbot, right? Or how, what is the process, what are the algorithms of natural language processing, right? Hope you like this session. Thank you.